Good evening to all. So let us go for DC armature winding, so which is a simplex lap winding. So considering the first numerical, which consists of 30 conductors, 4 poles, and type of winding. So simplex progressive lap double layer. So as usual, consider the dimensions. So go for units, enter centimeters, consider the centimeters, say OK. Next limits, enter 0, 0, enter 0, 0, enter. Next 500, 500, enter. Next go for zoom, enter, enter. So now the workspace is ready to draw the diagram. So consider the first conductor, draw a line of some dimension. Next, to come out of the command, so press space button. So now there are 30 conductors. So from here I have to consider the 30 conductors. So type array, enter. So here go for rectangular array. So number of rows will be 1, columns will be number of conductors, row offset 1, column offset, that is the distance between the two conductors. So I'll consider it as 20. So please remember column offset 20 for calculating the poles. So this will be required at that particular time. So column offset 20. Now go for select the object. So select this line, enter, and say OK. So we'll get 30 conductors. So since it is a double layer winding, so go for the second bilayer, go for others, go for load. So consider ISO dash space for bottom conductors since it is a double layer winding. Say OK, say OK. So now select all the even conductors one by one. So after selecting this again, so we have to go for bilayer where we have selected the others. So here consider the dotted conductor, and next press space button, close. So now we are having the total 30 conductors which are having both top as well as the bottom conductors. So now number the conductors. So go for M text, type M text, enter. So now it is asking specify the first corner. I'll specify the first corner and I'll click here. That is the second corner. So we will be getting this window. So now just I'll go for typing the only odd numbers. So go for resizing, resize as 10. Say OK. So now just you drag this and drop exactly where there is a space switch of the ortho. So just you click here. So double click on this. So just you extend this line up to 30 conductors. Now type only the even conductors. So 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Say OK. So now as per the winding table, So go for winding table. So first conductor is connected to the 8th conductor. So go for line, consider the first conductor and connect to the 8th conductor. Extend the line up to 8th conductor. So now go for enter space button. So now this has to be rotated. So go for rotate. Select this object. Go for again space button. So now it is asking specify the base point. So consider this as the base point. And again space. Sorry. So go for rotate. Select the object. Enter. Go for specify base point at the first conductor. And it is asking specify the rotation angle. So here I'll specify the rotation angle as 45 degrees and enter. Now again draw another line from first conductor to 8th conductor. Enter. Now go for again rotate. Select this object. Select the line. Enter. Select the base point at the 8th conductor. Specify the rotation angle as minus 45 and enter. So now this is the extra overhang point. So go for trim command, right click and trim the extra object and come out of space. Now select this line, go for considering the dotted line. So now it has to be connected to the other conductors. So if you see, one is connected to 8 as per the winding table. So next 3 will be connected to 10, that is only the back pitch as per the winding table. 3 is connected to 10. Next 5 is connected to 12. So go for array, enter. So now only the solid line has to be connected. So number of columns will be 15 and now the column offset. So from first conductor to second conductor is 20. So now for first to third it will be 40. So column offset will be 40. Now select the two objects. Enter. Now say OK. So since if you see always it will be traced from left towards right, so we cannot go make an array towards the left. So go for copy. So select these two lines, enter. Go for copy, select these two lines, enter. Now it is asking specify the base point. So consider this as the base point. Just move and just click on the lines. So now enter, come out of the command. So now similarly at the front pitch. So this is the back pitch side. So now let us go for the front pitch. As per the winding table, front pitch. So 1 is connected to 6 or 3 is connected to 8. Connect 3 to 8, enter. Now go for rotate, select the object, enter. Select the base point at conductor 3. Now go for rotation angle as minus 45 degrees, enter. Now again go for line, draw line from 3 to 8, enter. Next go for rotate, select the object, select this line, enter. Take the base point as 8. Now type 45 degrees, enter. Again go for trim command, right click, so trim the unwanted portion, enter. Now this is the dotted line, select the dotted line. So now again go for array, enter. So now columns will be 15 because already one is been, sorry, columns will be 14 because one conductor has been already left towards left. So consider 14. Column offset will be 4. Select the object. So select these two conductors, enter and say OK. So now these three conductors has not been connected. So go for copy. So select these two lines, enter. Consider this as the base point. And just click exactly on the 6th, 4 and 2. Now enter to come out of the command. So now as per the winding table, these are the end conductors. So these are the back pitch end conductors, these are the front pitch end conductors. So both you can see towards left as well as towards right. So now as per the winding table, so 25 is connected to 2. So just already we have having the numbers here. So just you can go for copy and again you can go for a click and sorry, there is no paste option. So Control V, or just you go for select Control C and Control V. So these numbers will be edited. So this will be delete the rest of the other conductors. So 25 is connected to 2 at the back pitch, 27 is connected to 4 at the back pitch, and 29 is connected to 6 at the back pitch. So similarly I'll go for Control C and Control V. So here 2 is connected to 25. So this is the second conductor, so it will be connected to 25. 25. Next this will be 27, and next this will be 29. So just if you want, you can move this. Okay, so similarly while coming to the front pitch, so this is 27 is connected to 2 and 4. Double click, delete this. So again same, so Control C, Control V. So this will be 27 and 29. So double click, delete this. So 27 and 29. So now this is as per the winding table. So if you see, 2 is connected to 27 and 4 is connected to 29. So 4 is connected to 29. So now to draw the commutator segments, so draw a line from the end to some distance. There is no dimension. Draw line. Enter. So now how many lines has to be drawn? So there are 15 plus 2, so 17 are there. So go for array. Enter. So here 17 columns will be 17 columns and column offset will be 40. Select the object. So select this line, enter and say OK. So now draw a line from this end to this end, enter. So since the commutator segment which will be connected 50% towards right as well as 50% towards left, so consider the column offset of 20. Go for line. So from here extend a line of 20 centimeters, enter. Similarly go for line, extend this 20 centimeters, enter. So now just draw a line vertically and extend this, enter. Now again, so the segments will be exactly kept at the between the two endpoints. So now go for array, enter. So there will be columns will be 18. Select the object, select this line, enter, say OK. So now just go for line and draw a line here. So these are the commutator segments. So how to number the commutator segments? So if you see here, this is the first conductor which is connected to this segment. So consider this as the first commutator segment. So already the numbers has been displayed here. So go for control, select that, control C and control V. So this will be your first conductor. So you can rename the numbers, delete. So this will be the first commutator segment. So space, next 2, next 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So these are the 15 commutator segments. Say OK. Now if you see, these are the two end commutator segments. So if you see, 2 is connected to 27. So that is commutator segment is 14. So copy this, control V. So name this as 14th segment and name this as 15th segment. So as per the conductor which has been connected. So this completes the number of commutator segments. So now we have to fix the poles and we have to go for the direction of rotation. So to fix the poles, we have to go for certain calculation. So when we go for the calculation, so go for calculator. So as per the calculation, what is the tau? Tau is the pole pitch. So pole pitch will be equal to Z by P into distance between the two conductors. So what is Z? So Z is 30 conductors. So divided by, so number of poles are 4 poles equals 7.5 into what is the distance between the two conductors? So that is column offset. So column offset we are considered as 20. So type 20 and equals. So this is your total pole pitch. So one pole pitch is equal to 150. So what is pole arc? Pole arc is equal to 0.7 times pole pitch. So into 0.7 equals. So 105 is your pole arc width. So close the calculator. So now go for rectangle. So go for rectangle. So now it is asking specify the first corner. I'll specify the first corner. So I'll not specify the second corner because I know the dimension. So dimension is been given here. So in the command space type D and enter. So now it is asking specify the length. So length is 105. That is your pole arc. Enter. So what is the pole width it is asking? So any width we can specify. So it can be 20 or it can be 30. So don't go more than 30. So I'll specify it as 30 and enter. So this is your pole arc which has been measured. So enter or click there. So now the pole has been fixed. So from the first conductor, so what is the dimension? So that is 0.15 times tau. So again go for calculator. So when I go for calculator, just a second. So which is nothing but 0.15 into pole pitch. So pole pitch is 150. So equals. So that is 22.5 centimeters will be your dimension from the first conductor. So go for line. So from the center, draw a line which is of 22.5 centimeters. Enter. So enter. So now go for copy, select this pole arc, enter, select this corner and move the pole and switch off the ortho, and exactly at the corner of this line to fix the pole. So now we can delete this line. So number of poles are 4 poles. So go for array, enter. So number of columns I'll go for 4, and what is the column offset? So I'll consider the pole pitch, that is 150 as per the calculation. Now select the object. So select this object, enter, say OK. So now number of poles has been fixed. So now consider the direction of rotation for the winding diagram. So let us consider the generator. So according to the generator, so it will be moving in a clockwise direction. So go for polyline. So draw a line. So consider 2 points here, and now I need the arrow. So to get the arrow, so there is a width here, type W, enter. Now I'll specify the width of the arrow as 20, enter, or we can go for 50, enter. So end width will be 0, enter. So now this will be our direction. Or suppose if I want to reduce, again I can go for width, enter. So I'll go for width as 25, enter, 0, enter. So I can reduce the arrow, enter. So this is for direction of rotation for the generator. So I can go for texting here. Direction of induced EMF for generator. So since this is the direction of induced EMF, so I'll consider the number of poles as 4 poles. So here it will be north pole, south pole, and north pole, south pole. So again go for copy this. Again text is there, no need to type once again. So double click on this. So this has north pole, south pole, north pole, has the south pole. Say OK. So now to show the direction, so go for polyline. So just click here. So W, enter. So just a small dimension is required. Go for 5 as the starting width and 0 as the ending width, and enter. So move the mouse. So we'll be getting a arrow. So now go for copy. So select this, enter. So select the base point as this corner, and just within the switch of the ortho. So within the pole, just to show the direction of rotation. So this is for north pole, it will be downward direction, and for south pole, so it will be upward direction. So just go for rotate, select this, enter, select the base point, type 180 degrees. Now go for copy, select the arrow, enter, select this, so show the EMF induced. So delete this and then delete the number of poles. So next we have to go for fixing the brushes and brush polarity. So to fix the brushes, so consider the midpoint of the pole. So go for line, so just move the mouse or cursor, so you'll be getting the midpoint. So from here draw line vertically, switch on the ortho, draw line vertically to some distance. So now enter, come out of the command. So now to fix the width of the brush, so for simplex it is one segment width. So if you see the first procedure, fifth point, so it is one segment width. So one segment width, which is nothing but 1 centimeter, so which is nothing but whatever the dimension of the commutator segment. So this commutator segment width will be almost 20. So consider a line from here, the dimension, sorry, 40 will be the commutator. So once again I'll repeat, go for a line. So from here select, move the mouse towards right, type 20, enter, escape. Again from here select a line, move towards left, type 20, enter. So it will be 40. So just you draw a line, extend this line. So now delete this vertical line. So this is the brush width and segment width. So how many brushes are there? 4 brushes are there. Again go for array, enter. So same 4, column offset will be 150. Select the object, so select the brush, enter, and say OK. So now 4 brushes has been fixed. So brush the polarities. So brushes has to be mentioned with polarities. So as per the data and as per the procedure, so under north pole for generator it will be positive brush polarity. So go for Control C, Control V. So click here, double click. So under north pole it is positive brush polarity, under south pole it is negative brush polarity. So again here it is positive brush polarity. Next here it is a negative brush polarity. So if you want to increase the size, you can increase the size as 20. Say OK. Suppose if it is coming down, just you extend this and delete here. So delete and get it within the box. So name the brush polarities, Control C, Control V. So I'll name this as brush A, this as brush B, this as brush C, this as brush D. So you can change the size, set 10. So, okay. If you want to keep 20, you can keep 20 also, no problem. This is the brush polarity with names. Enter. So, okay. So now just draw a line to some distance. Again from here, a line, connect with respect to the polarities. So since here it is jump, go for circle. So draw circle here, go for trim command, right click, so trim the circle, this line, give a jump, so escape, so type Ctrl C, Ctrl V. So this is the negative brush polarity. Ctrl C, Ctrl V. This will be the positive brush polarity. So this is with respect to brushes. Please remember, so for progressive lap and retrogressive wave under north pole, it is positive brush polarity. So now let us go for drawing the sequence diagram. So as per the winding table, the sequence will be framed. So draw a line to some distance, escape. So now with respect to this, so as per the winding table, there are 31 conductors. So go for array, enter. So number of columns will be 31 and column offset again I'll consider it as 20. Now select the object, enter, say OK. So now connect the, delete, go for line. So connect the line from first to last conductor at the top, that is back pitch. Again at the front pitch, draw a line, enter. Now go for trim command, right click. So here trim the bottom of first alternative. So trim here at the top. So go for trimming the alternative line. So trim this. So once the trimming is been done, escape, come out of the command. So now we can number the commutator segments. So copy this, Ctrl C, Ctrl V. So these are the odd conductors. So just I'll double click on this. So this is 1. So go as per the winding table. So 1, then it will be 3, 1, 3. Next this will be 5 as per the winding table. So this will be 7. This will be 9, So here it will be 11. So here it will be 13. And this will be 15. Next 17, 19, 21, 23, 25, 27, 29, and this is 1 as per the winding table. Odd numbers. Say OK. So similarly go for even numbers. Control V. So double click. So if it is confusing, just we can move a little bit below. Yes, now double click on this. So now this will be 2, sorry, not 2, it will be 8 as per the winding table. 1 is connected to 8. So 1 is connected to 8. So next it is connected to 10. So this is 12. Next 14. Next it is 16. Next 18, 20, 22, 24, 26, 28, 30, next 2, next 4. So extend this, 6. So the sequence diagram will be numbered as per the winding table. So now the directions has to be shown on the sequence. So the direction will be taken from the poles. So if you see the first brush polarity, so which has been connected to this segment, and this is the conductor where the current will be passing, that is 3 and 8. So 8 doesn't have any direction, so interpole can have any direction. So 3 is having downward direction. So copy the arrow, enter, take this as the base point. So now see where is conductor 3. So switch off the ortho. So this is the third conductor. So here this will be downward direction. So and here 8. So since it is a positive brush polarity, both it will have a downward direction. So or else leave as it is. Generally polarities will have both downward direction, positive brush polarity. Escape. So consider this as first brush, A. Next I'll coming to the second brush, this is the B. So where the conductor which is having 9, 14, or if you can just see, it will be connected to the other conductor, that is 11 and 16. So better we'll go for 14 and 9. So go for copy, select this, enter. So check where is 9 and 14. So 9 and 14 it is here. So 9 and 14, so both upward direction. Excuse me. So this is the negative brush polarity. So draw a line, negative brush polarity, enter. So similarly go for copy, so north pole, select both the direction, enter. Consider this as the base point, see which is the conductor which is having the brush polarity. So that is 17 and 22. Check where is 17 and 22. So here is the 17 and 22. So consider this as positive brush polarity, and similarly copy, so select south pole, enter, select this as the base point. So see in the brush D, this is the conductor, so 25 and 30. So check where is 25 and 30. So here is the 25 and 30 conductor, select this, enter. So now brush this polarity, so show the brush polarity which is positive and which is negative. So Control C, Control V, so double click, just go for arranging the polarities properly. So if you want, you can take the alphabets also. So Control V, so now go for alternative direction. So since this is downward, so this will be having upward direction. Since it is downward, this will be having upward direction. So go for copy any one direction, so either down or upward direction, select this, enter. So select the base point. So since this is down, this will be up. Next conductor, this will be down, up, down. So this is up, so this is up. Next this will be down, up, this will be down, up, down, up, this is down, down, up. So this will be having downward direction, upward direction, downward direction, upward direction, downward direction. This is upward direction, so this is up, this will be down, up, downward direction, upward direction, downward direction. Now come out of the command, again copy the upward direction, enter, select this, so go for upward direction. So automatically the direction will be arranged exactly. So you can switch off the ortho. So finally come out of the command. So you have to verify that first conductor is upward direction. Here also the first conductor must have upward direction, then only your sequence diagram will be correct. So this completes your first numerical. So save this numerical and take the printout and number the question number, so which has been done. So save the file. So to convert it to PDF, so you can save did drawing 1 or DC armature problem 1. So save the file in DWG